we'll look at factoring trinomials. And we'll start with the type that are x squared plus bx plus c. So the important thing here is that there's no coefficient of x squared. And the idea here is we're looking for numbers p and q to factor this into, where p plus q is equal to b and p times q is equal to c. So, some examples. We'll start with this one, x squared plus 6x plus 8. So when we're dealing with these, we should start with the c term. We're looking for two numbers that multiply to be 8. So let's think of things that multiply to be 8. Well, 1 and 8, and also 2 and 4. And then we can add those numbers. 1 plus 8 is 9, 2 plus 4 is 6. We need them to add to be 6. So that's the second case. X plus 2, x plus 4. Another example, x squared minus 7x plus 10. So we need two things that multiply to be 10. That could be 1 and 10, or 2 and 5. If I try to add these, 1 plus 10 is 11, and 2 plus 5 is 7. However, you'll notice we don't actually need 7, we need negative 7. So it's now also important to realize that negative 2, negative 5 also multiply to be positive 10, and add to be negative 7. So this is x minus 2, x minus 5. Another example, x squared minus 4x minus 12. So now we need things that multiply to be negative 12. This becomes a little trickier. We could do negative 1 and 12, or 1 and negative 12. Negative 2 and 6, or 2 and negative 6. Negative 3 and 4, or 3 and negative 4. And then we should add these. This is 11 minus 11, 4 minus 4, 1 and minus 1. And we need them to be the negative 4. So now I have x plus 2, x minus 6. This time we need numbers that multiply to be negative 15. Negative 1 and 15, or 1 and negative 15. Negative 3 and 5, or 3 and negative 5. These add to be 14, negative 14, 2, and negative 2. And we need a positive 2. So x minus 3, x plus 5. And when we're factoring these, it doesn't matter which term we write first. I could have also written this as x plus 5 times x minus 3. We'll now look at x squared plus 4. So we need numbers that multiply to be 4, which could be 1 and 4, or 2 and 2. You'll notice there's no x term, which means we need things that add to be 0. And that's impossible here. So we can say that this one's prime, since there's no number that multiplies to be 4 and adds to be 0. The next thing we'll look at is factoring by grouping. And factoring by grouping is going to look at things that have in common. It's going to be the same type of factoring by a common factor. Here we see that both of these things have an x minus 3. So if I try to remove it, in my first term I'm left with an x. My second term has a 4. So this factors into x minus 3, x plus 4. With this one, I can see they both have an x plus 2. And when we're looking at things with exponents, we take the smaller exponent. So they both have an x plus 2 squared. They also have this x minus 5, and the smaller exponent is 3. So when I remove these, I'm left with a 7. I'm also left with an x plus 2 since I only removed one of those, or I removed 2 of those. I also have a minus 2, and I've only removed 3 of the x minus 5s. So now this is the type of problems we actually use factoring by grouping. And the idea is to look at them in pieces. If I look at the first piece, I can see they have an x squared in common. And I'm left with x minus 3. If I look at the second 2 parts, they have a 4 in common. And I'm left with an x minus 3. And now it's important to see that they have this x minus 3 in common. And when I remove that, I'm left with x squared plus 4.